and we'll be looking at statistics. But before that, on Monday, I'll put up an assignment, right? It should cover all the topics that we have looked at. And that assignment will be over 40. And then that particular assignment, your submission will be, I think, Monday. And please, after Monday, if you try even submitting it won't work, because I noticed that a lot of you have the habit of ignoring submission dates and deciding to submit when you are comfortable. Please endeavor to do that assignment. It will be a big pillar in your continuous assessment. Okay. So I'm giving you from Monday, that is 1 week. So if you don't submit, nobody should call me for any other issue. Do you understand? Okay. Yes, please. Louder, I can't hear. 1 week, from Monday to Monday. Yes. So anytime within Monday, I'll put it on the platform. I'm yet to set the question. So, okay. What? 1 week. Next week, Monday is what day? Is what? Next week, Monday. Can someone check? 4th. So that will be it. Because when I looked at your grades, we have about 7 assignments now. Some people haven't even attempted any. Some have only 1. Why? It's important to, unless during the examination, you intend to get everything, because you need to pass. So don't take it like as a joke, please. So I'm giving, because of that, those who have issues here and there can use this particular assignment to cover. So please, if you've never been in class, today is your first time or whichever, make sure that you do that assignment. Okay, all right. So those who are not here, when they come, let them know, okay? So let's continue with for today's topic, statistics. So we are looking at frequency distribution tables. Frequency distribution table. So we are saying it's a tabular arrangement of data by grouping them into classes. And then when there's a repeated observation on a particular class or a particular group, that observation is the frequency. That is, if it's keep occurring, that is the frequency of that occurrence. So you can have a frequency table. So we gave an example of votes where we have annual, and Kwame. And the repeated observations on them are the votes counted. So the number of votes, each vote that has been counted is a repetition, isn't it? Because the same annual, and you are repeating the votes applied to annual or annual coming. So the number of votes is the frequency. So this is a frequency table. And we gave an example of a set of data. And then we are asked to do a frequency table. Okay. So assuming we have this data, you realize that that data has is within the ranges of what? 0 to what? 6. Yeah, it's within that range. So when you look at range 0 to 6, right? The repeated observation will be what? You look at 0. How many observations were on 0? How many observations was on 1? How many observations was on 2? That's how you get your frequency on those numbers. Okay, so it's not always that you have nominal values like ANOVA, they are names, so they are nominal, like ANOVA, well, call me, and it can be numbers too, okay? So here they are numbers, and we want to see the frequency, the number of children. You use the tally. You realize that the tally is more or less, it helps you track the observations, okay? It helps you track the observation in order to get your frequency right. Because sometimes the data could be a lot. You can have a lot of data. So you can't just look at it and count. Okay, 4, you keep counting. You make a mistake. So the tally guide to it helps you to be able to get your frequency right. So when you look here, you realize that we have 0 here, and then you start from the first number, and it is 2. You don't necessarily start from 0, but you start from the first number so that you make sure that you have counted every number you have there. So you start from the first number. That is 2, isn't it? So you take 2, you take 1, you make a tick there. Then we have another 2. Then you take, isn't it? Then what we have? 4. Then you move to 4. You take. 3, you take. But when you get to 4, you realize that 1, 2, 3, 4. The fifth one is what is canceling. Do you get it? So that it makes counting easy. You know that every cross is 5. So assuming even this is 100, and you have 5 of this, you can simply count 5, 10, 15, 20, then you are done. Instead of counting 1, 2, 3. Do you get it? So after the 4th strike, and then you cross it with the 5th. Okay, so you realize that 4 has 8 observations. You agree? Yes, because this is 5, this is 3, 8. So that's how the tally is done. You understand? Okay. So with the tally, we've been able to have our frequency. And then you just write the frequency. That's fine. So with the frequency, there's something we call graphical representation. Sometimes you may have the numbers, right? To make it easy to read and understand, and then maybe just a look at it, you see what is going on without necessarily looking at the numbers and analyzing it in your brains. Sometimes when it's represented graphically, it makes it at a goal. You consider, oh, okay, this is how this data behaves. This is how this data is, okay? God willing, when you join us at Unimac and you are doing your project work or any, I'm talking of your thesis, at the end of the day, when you collect your data, you present it graphically. After having your data, it's good to present it graphically so that it's easy to understand. Okay, when I collected the data, this is how it behaves. You get it? So you can use a bar chart, you can use a pie chart, you can use a histogram. Okay. So there are a lot of ways of presenting data graphically. There are a lot. Okay, there are a lot. We have scatter diagram. There are a lot, but we just limit ourselves to these three for the purpose of this class, okay? Okay, so pie chart. So we'll borrow the example we used in the first slide. We have annual, and coming. You see the data is like that. You can present it in a pie chart form so that when you just look at it, it just gives you, okay, this is the proportions, this is the fraction, this is how it looks like, okay? So assuming you have this data and you've been asked to draw a chart, a pie chart to illustrate the information. And then you've been asked to find what fraction of the votes was cast for annual. Okay. So you need to know the total number of votes. And you know that is what? The total frequency. Okay. And then you should also know that the total angle of a circle is what? 360. Okay. So in order to represent it in a pie chart form, you know, pie chart is 360. The angle there is 360, right? So you need to change the votes that you have, right, into the degrees corresponding to 360. So how do you do that? You realize that the number of votes, right, assuming you are looking at annual, the number of votes for annual is a fraction of the total frequency. You agree? Good. So if it's the fraction of the total frequency, and then you need to, and then you know that the total frequency, when you want to change it to pie chart, is equal to the 360 degrees, isn't it? So you want to find that sector, that part of the pie chart, and that part of the circle, right? That represents what? Annual, right? So it is a fraction of the 360, right? That's what represents annual. So you have to find, you know that 6 over 360 is what? The fraction of the frequency. Then you multiply it by what? The 360 to get the portion that annual represents on the pie chart. Okay. The same applies to annual. Annual is, the vote is 12. You need to find what? The fraction. So we have 12 over 36 times 360. And that will give you what? 120 degrees. And then coming to get 180. So you realize that when you add this, you're supposed to get what? 360. Okay. So with that, you can draw your pie chart with and you name it with the degrees, then like that. So we have annual 120, annual 20, and coming 180. This is your pie chart. Okay. So we were asked to find the fraction of votes cast for annual. The fraction of votes cast for annual is the same. You remember when we were calculating for annuals, the degrees that is taken on the pie chart. We got the fraction of votes and multiplied it by what? 360. It's the same thing. In other words, too, since you also know annual here, we can also use the same pie chart to get the fraction by using 120 over what? 360. And it should give you what? 1 over 3. Right? Any questions? Okay, let's move on. So that's the alternative way to do it. 120 over 360 to also give you 1 over 3. Okay, so you can also be given a pie chart, and then you are supposed to what? Interpret it or answer the same way you are able to use the data to give us a pie chart. You can also use the pie chart to interpret the data. Okay, so assuming you are given a pie chart like that, and then you'll be asked questions on it. So the pie chart shows the monthly expenditure of Mr. Siedu, whose monthly income is 1,800 Ghana cedis. What fraction of Mr. Siedu's income is spent on food? What fraction of Mr. Siedu's income is spent on food? I would want someone to help out with this. Would you do as the honors? Okay. What fraction of Mr. Siedu's income is spent on food? You said it's what? Can you explain? Okay. Do you agree? How much does Mr. Siedu spend on rent? Who will try this? How much? Yes, please. Let me give you the mic because we can't hear you.
Okay, as we know that an angle is at 90 degrees, it shows over there that the rent is 90 degrees over there. So it's going to be 90 degrees over 360.
That is the fraction. You've given us the fraction. I'm asking how much? How much? I'm talking of monetary terms. How much does Mr. Siedu spend on rent? So, who else can give a try? Yes, please, again. Right. Then how much did you get? Do you agree? So that means that having the fraction, meaning the 180 is you are trying to get a fraction of the 1,800, isn't it? Yes, a fraction of the 1,800 is spent on food. So you need to find the fraction first, then you multiply it by what? The 1,800. Okay. Yes, yes. Yes. When you get 90 over 360, what fraction do you get? What is the fraction of 90 over 360? So that's 1/4. Do you understand that? So it's the same thing you are saying. But you need to understand that it is the fraction you are looking for because you multiply it by the total, right? Because the 1/4 is the same as 1/4. So if you divide it into 4, 1 out of the 4, you understand? Okay, and then we have savings. What is the value of the angle that represents savings? Who will try? Yes, my dear. Okay, thank you. You agree? Good. So that's for the angle of food. We all agreed it was 1/3, isn't it? And an angle of rent, a monthly amount spent on rent. We all agreed it was 450. Total angle of a circle, angle representing savings, sorry. That is the explanation she gave. Okay, so we'll be getting what? 40 degrees. Agreed. Thank you. There's another example here. So we have a pie chart shows distribution of books borrowed from a school library. The number of mathematics books borrowed was what? 228. We've been given the number of mathematics books that was borrowed, right? Okay. So with that information, we have to find what value of the angle, the value of the angle that represents economics, the total number of books borrowed, and what percentage of books borrowed does biology represent? So, can we go on? So the angle that represents economics, angle that represents economics, who is coming in? Angle that represents economics. Oh, sure, do.
Please, you sum up all the angles equivalent to 360. Then you subtract it from the 360 and you get 65 degrees.
You all agree? Good. So that would be angle that represents economics. That's the explanation he gave. We added all the angles. And that's 65 degrees. And we've been asked to find what? Total number of books borrowed. Here, you realize that we have been given so if you want to know the total number of books borrowed, we know that 360 would represent the total number of books borrowed. Agreed. So if you have that, yes, it's two ways. You can do your cross multiplication or you can do this. Agreed. So, but okay, you can use the if more or less divide or you can use the cross multiplication. Whichever, you get the same answer. Okay. Are you okay? Any? Okay. And we are asked to percentage of books borrowed. The percentage of books borrowed represented by biology. So here, you still need to find a fraction and then multiply it by what? 100%. Because it's a percentage you are finding now. If you wanted to find amount on income, it would be the fraction by the income. But here we are looking at the percentage, right? So it will be the fraction of that of biology by multiplied by what? 100 to get percentage, right? Okay. So we have 22.22%. 80 over 360 times 100, and that will give us 22.22%. Okay, so let's look at the next slide. So this is a bar chart, histogram, and then measures of central tendency. So as I said earlier, these charts are to represent the data visually so that you just see a picture of it and then you can interpret. So this is just an example to see. There are various forms. This is more or less like a 3D type. And then you can also draw in your graphs, the flat ones. They are all bar charts, okay? So let's look at an example where you have a frequency table and then draw a bar chart for the distribution. And then people chosen at random from the class. Our probability is coming here to the people chosen at random from the class. What is the probability that the people obtain 7 marks, 3 marks, 6 marks? Okay, so let's look at, and then 4 marks, right? Okay. So this is how the bar chart will look like. You realize that you have your marks out of 10 here. You have 2, 3, 4, 5, 6, 7, 8, right? So 2, realize that 2 is what? 9. There, you draw it up there. So this one is not like a solution to any, it's just representing this data as it is. You get it? So you have your 2, and that is what? 9. 4 is what? 14. What? 4 is what? 13, right? 7 is what? 5. See? So someone, well, 8, okay. Someone can just look at the bar chart and see, oh, okay, this is how the data looks like. Okay, and even looking at it, some may be able to tell you some properties of the data, how the data looks like. You get it? So it's important to do it like that. Okay, and we are asked to find the probability that the people obtain 7 marks I shouldn't have. I should have made you do this. Anyway, why do we have 8/64? Can someone explain? Why is 8/64 or 1/8? Yes.
We added the total frequency, giving us the 64, and then the mark represents 7 is 8. So we 8/64, then we break it down to this one.
Thank you. So here, the probability is only on 7 marks. It said 7 marks, so you just focus on 7 marks. Okay, okay, thank you. I hope you all agree and you are okay. So the probability that people obtain 3 marks, 3 marks, and 3 is what? 14. So 14/64. 6 marks. 6 marks. Thank you. That's great. All right, this is more than 6 marks, not 6 marks. I didn't read it right. Okay, 6 marks is correct. More than 6 marks. More than 6 marks. So 6 is not part. More than 6 marks. So 6 is not part. So you start from 8, 2, and 3. Then you get your probability. So it's 13/64. So sometimes you really need to read the question to understand it. Less than 4 marks. This one I left it for you. Less than 4 marks. Raise your hand if you want to answer. You want to answer? Less than 4 marks.
It's less than 4, so that's 2 and 3.
2 and 3 is giving us what? 23. Okay, and all over what? 64. All right. So histogram, we didn't really delve much in histogram because histogram bar charts, they are similar. The only difference is that the histogram, they are together. You don't have spaces in between. So it's more or less like it's continuous. Okay, it's continuous. So as I said, yeah, there are no gaps in the rectangles. So this is how the histogram will look like as compared to the bar chart that we did. This one is continuous. The difference of the continuity is that you realize that it's just that this one, I couldn't put this two here, but this two would be here. Look at it carefully. You realize that this is 2. So from here, when you read it, the data will look like from 0 to 2. Within that range, they are all here. So you continue from 2 to 3. You get it? 3, 4, 5, 6. You see, there are no gaps. So it's continuous, right? So the bars are not standing distinct of each other. They are together. So the measures of central tendencies, that one has a lot of examples, and so that one will take more of our time. So, and we said they are the averages of the distribution, right? And that is mean, mode, median. All right. So how do you understand mean? What is mean? Or what is average? What is mean? When we say mean, you need to understand what is mean. Just but the answer I want is not probably some. I just want to know what you understand by mean, off head, like how you understand it. You use it, you use, okay, the average, you use it daily, don't you? You use it. So in using it, what do you imply? What do you want to, what is average?
Average. So, per my understanding, if you are considering the average of something, you are looking at the middle ground of sorts. Yes. In terms of the overall, you see, so when you take the whole situation and you find the middle ground average. What is median? All right. So if the mean can be considered as the average of the numbers, you know, and then the median, okay, yes, that is also very true.
You have tried. You are laughing. Okay, someone else. Okay, there's someone here.
Okay, so to my understanding, I understand that when we talk about the mean, it's not, you are looking out for something, not more or less. When you are looking at something, you are not looking at the more of it or the less of it. It has to be within the equilibrium of it.
You've all tried, you have the understanding. It's just that when we say mean or an average, right, we are talking about what can be applied to all and it will still fit. You mean like we are looking at an average mark, right? You are looking at, okay, the whole class. Okay, let's say we are having the whole class, and then we want to say, okay, looking at the class assignment, what is the average mark? It means that without the individual marks, that average mark should still be able to apply to all of you and still fit. Do you understand? Okay, what I'm saying is that an average, right? Assuming you are using the marks, like I said, the mark, the average mark for the class, right? It should be a mark, right? That can apply to everybody here and still fit perfectly. Because why? It is the individual mark that has been put together, right? Divided by the number of people in the class. So without the individual mark, assuming we don't have the individual mark here, but we know the average, assuming we have calculated the average already, and then the individual mark is lost somewhere, we don't have it. That average mark can be given to everybody here. Okay, so the average of, a situation or an average of, assuming there's a situation and you're talking of the average, it means that is a state where he said equilibrium. Well, sort of, but it's more or less out. It's more or less like a point where it can apply to all the participants, right? An average situation, it's okay. It's all right. You get it. Your question? Yes, please do.
You're not supposed to make contributions. Somebody brings 5 CDs, somebody brings 10, somebody brings 20. If we put all together and decide to share it equally, right? What the average is what everybody will get if we share it equally.
Do you understand what he's saying? In monetary terms, I think that one is better because when it comes to money, we seem to understand. So assuming everybody brings some amount of money, some bring what? 30, 5, 10, 20, 10, 5, and we put it together, right? And want to share it, right? If we want to share it equally, for everybody to have the same, what do? We put the monies together, right? And divide it by what? The number of people. So that amount everybody is getting, isn't it the average for everybody? You get it? Yeah. So it's the point where, well, not above, not below. Okay. Is there anything? I saw someone's hand up. Okay. So when we talk of mode is
the number that occur most.
the value with the highest frequency. That is the mode. And I was saying that assuming you have 3, 4 numbers that are occurring, are all occurring at the highest, as in you can have more than one mode, you can have more than 2, 3, it can be multimodal. So you are not limited to having only one mode, because there are some data where, assuming we're talking of the class marks, there are people, there are marks that can occur like 10, 9, 8, right? The number of occurrences of 10, maybe 20 people had 10, 20 people had 8, 20 people had 9, right? If those are the highest occurrences, are they not all modes? So you are not limited to only one mode. And then median.
Please, question on the mode. Is it if it's mode, why then they be asked to, like, what is the modal? Is there any difference? Or answer that is adjectiva. So mode and the mode and the modal. Which one? Which is which?
Same. But when you say modal, you add what? Modal value. But mode is mode. What is the mode? You end there. It's English. It's the same. What is the modal value? You can't say what is the modal. It's English. It's all the same. So there's no.
If you have more than 2 modes, do you need to add all the modes together, or you list them separately?
You list them separate. If you say, okay, the data is by modal. The modes are 8, 9, 10, 8, sorry, by modal 2. So 8, 9, right? Whichever you list them, you don't add anything. Okay. Yeah. Multimodal, right? Multimodal. Okay. If you want to be using the French, or you want what? Quadrimodal or sync modal, whichever, but multimodal will keep you safe. So mean, in calculating mean, right, you have two ways. When you have a set of data that is not quite large, right, you can simply use this this equation. Like, this is what I just explained to you, that in this class, if you want to find the average, what you add, what you add the frequencies, and then what you add the values, then divide it by the number of the that is the total value. Okay, so find the mean. Let's use an example here to be more clear. So you have this set of data 0, 2, 1, 3, 4, 4, and 5, 5. And you're asked to find the mean. The x1, x2, x3, they are what? The numbers that you are seeing there, right? And the n is what? Huh? The n. The n is not the summation. Thank you. The n is the number of. The n is the 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's not summation. Summation, this symbol here is summation. So it's this that you sum all over the number of individual elements. Yes. 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 The xn means that up to the last, so here xn, it will be x8. That is this. This is x8. It's just a representation, so you just need to understand that this x1, because they are all xx, we need to differentiate them. So x1 is this, the first one. X2 is this, the second one. So it's just a differentiating. Then xn is what? The last number, because we know that the n represents what? The number of elements. So n is 8. So the last number should be what? X8. Okay? So we have, so when you add here, you divide it by the 8, you get your average. You are cool. Good. Yes, please. X1. Yes. Yeah, I made it a subscript because it's just, it's just, how do I say it? We are just numbering them. You understand? It's a subscript, not necessarily, you can even use A1, A2, it's just a representation. This equation is for you to understand how to do it. Sometimes if you understand it, you don't necessarily always need to put the equation there, right? For this one, it's, but when you put the equation there, sometimes it helps you to remember how the process goes, right? So with this, if you decide to change x1, x2 to a1, a2, a3, remember that your summation 2 will be summation A. Okay. It's just a representation. It's not. Um, okay. So there's this example here, and it says that the average of 5 numbers, 4, 10, 24, x, and 16 is 13. Find the value of x. With the explanation I gave, how do you find x here?
So we have the 4, 10, 24 plus x plus 16 equated to 13 over 5. So we have 1, 2, 3, 4, 5. Then 13. Then you cross multiply and get your x.
So at any point, knowing that is why I said, if you have it in your head, whichever way the question is twisted, you should be able to do it, right? So for this one, you've been given the average already, and you just need to find your x, right? So that's it. So here is it. So our x is what? 11. You agree? Any questions? All right. Let's move on. Okay, this is a nice example. I would wish to write this. Class rep, can you do help me with this? Hey, we need to really clean this thing. Wow. You know, I was saying that when you are given an average, that means that that average can be applied to all, isn't it? So if you have this example, we are told that we have a class of 20, and the average is what? The average age is 15 years. We can say that without the individual ages, this 15 years should be applied to all, isn't it? So the question, the average age of a class of 20 students is 15 years. And the average age of another class of 30 students is 20 years. Find the average age of the students in the two classes. Who would come up? This one is so it to the board. Okay. Yes, it's okay. So we were saying that the average age of the classes. What did we say finding averages? We said that getting the total and dividing it by the number of what, either participants or variables or whatever, or elements, isn't it? So with this question, we first need to know the total what, years. Then we divide it by the total students, isn't it? So how do we do that? Let's look at class of 20 students. With a class of 20 students, what will be the total ages? You need to sum the total ages, right? We have 20 people and the average of age is what? 15 years. So in summing the total age is what? 20 by the 15. Understood? So class of 20 students is what? Ages, total ages of the class of 20 students is what? 20 by 15. And that will give us what? Okay. So the total ages of the class of 30 students is what? 30 by what? And that is what? Okay. So now we know the total ages of individual classes. We are asked to find the average age of the students in the two classes. So what do we do? You need to sum this to get the total ages of the two classes, right? So when you get the total ages of the two classes, how do we, at this point, how do we find the average age? Thank you. Okay, so total number of students is what? 30 plus 20, that's what? 50. So the average age of the two classes is what? Over what? And that is what? That's it. Yes. That's your answer. Any questions? Okay. So I always say that you need to understand the principle so that any way to be able to solve it. Which multiplication? There. Are you talking of 20 by 15? We need to find the total ages of the students. And I said that if you are given an average, that means that if you are given an average and you don't have the individual ages, that average can apply to everybody. So the total ages of the students in the class will be the 20, the number of students multiplied by the average age given. Okay, so that's how come we have had 20 by 15, 30 by 20. Yeah, okay. So here we are. Okay, so 300 years. Then class 230. The sum of the ages of class 2 students. Total ages 600. So the combined class is 50. Sum of ages combined is what, 900? So we have 18 years, okay? Okay, so now we are done with dealing with small data. When you are dealing with large data, right? When you use this, it may not give you an accurate estimation of your average. So we call something relative frequency. You need to use the relative frequency to calculate your mean or your average when you are talking of, when you are dealing with large data. So when you're dealing with large data, if you apply this, the sum all over there, it may not give you a good estimate. Okay, so we are moving on to relative frequency. So here we would have a table with our, all right, so the relative frequency is given by what? The mean using the relative frequency is given by what? The sigma fx over sigma f. And you know the sigma is what? Sum of, right? The fx is the relative frequency where you multiply what? Your frequency by the value, right? All over the total frequency. That will give you the mean, okay? So, assuming you have this data, and then you are asked to find the mean, you realize that this one, if you say you are going to add all, you get a number all right, but we want an accurate estimation, okay? So you apply in a workshop, the times taken by 120 trainees to identify a fault in a machine are shown in the following table. And we are asked to find what? The mean. So here, you realize that the equation for the mean is what? Sigma fx over sigma f. So that means that we need to find what? Fx, isn't it? So our fx is what? The values multiplied by what? The frequency. Okay. Hello. Yeah. So we have x by your f. So you multiply and you keep doing that until you do to the last one, right? And then you add it. You add your frequency, you add your fx. Then you get your sigma fx and you get your sigma f. And your mean would be what? This over that. You are done. It's quite simple, isn't it? So that is it. So doing that, we had what? 6.275. So the interpretation of that is that the interpretation of the mean that you have calculated is the average time taken by 120 students to identify a fault in the machine is 6.275. That is the average time. So if you don't have the individual time taken, you can apply this for everybody, isn't it? So that is the interpretation. You should also understand that. Yes, you can. Most often, sometimes you may be told to run it up. If you are not told to run it up, it's safer to do it like 2 decimal places, okay? Because sometimes for this, if you are rounding it to a whole number, it will just be 6 minutes, right? But if you're running up to 2 decimal places, to be what? It will be what? 2 decimal places. If you're running up to 2 decimal places, what will it be?
6.28.
Two decimal places. I'm hearing different answers. I think we should have done decimal places because something is happening here.
6.28 because the five behind the 7, when the decimal places, when it is from 5 and beyond, you add 1 to the one in front. But when it is lesser than 5, let's say if the 6 to 7 and the 5 is, let's say, 3, then it will be 6 to 7. But since the 5 is there, if we run it or we add that 1 point to the 7 to become 8.
Thank you. Thank you. Let me just take this to explain this thing to you. When you say two decimal places, that means after the decimal, there should be two numbers, okay? So two decimal places, if this 5, if the number here is equal or greater than 5, right? That means that you would have to add 1 to the number before it. So two decimal places for this would be 6.28. One decimal place will be what? 6.3. Okay. If you are running up to a whole number, since this 2 is less than 5, so it will be 6, isn't it? Yeah.
What's then the difference between the decimal place and the significant figures? Let's say you are supposed to run it up to 2 significant figures, and when they say decimal place, what's the difference?
Okay. Assuming that you are with me. Assuming that you have here 6.035, and you're asked to significant figures. It will be, what did I say? 0, okay, assuming it's 6.075, right? And you are asked to two significant figures. It will be 6.075. Or if there are 0 beyond here, assuming you have 6.2000, usually the 0 is not recognized as a significant figure. But most often, if it is like this and you're asked to do two significant figures, it's the same as the two decimal places. Okay. Do you understand? So if you don't have zeros in there, it's the same thing. Okay. I think we should have done decimal places so that, yes.
I just want to clarify this. You see, we have the two significant figures, as you said, and then run to 2 decimal places and leave your answer in 2 decimal places. So I would like to know the difference between all of them. Run to 2 decimal places, leave your answer in 2 decimal places, and also with 2 significant figures.
It's the same thing. Listen, leave your answer in 2 decimal places. Is this running it when you are told to leave your answer in 2 decimal places? No, inadvertently you are supposed to run it. The fact that they haven't told you to run it doesn't mean that you should leave it. Do you understand? Assuming this, I said that leave your answer in 2 decimal places. it would be 6.28. You can't give me 6.27. Okay, if you are told, leave your answer in 2 decimal places, you are expected to apply the rule and do it right. Yes. Six 6.27. 6.27. You ignore the one. The Mhm.
Because when we are saying that when the decimal points are less than 5, they are more than 5.
Yes, because when it is more than 5, right, it's quite a significant point, right, for you to ignore. If it's more than 5, right, if it's less than 5, right, it's not that significant for you to add up. You get it? So here, having 5, it tells us that it's quite significant. So you need to what? Add 1 here. Okay. So you have 6.28. That is why. But if it is less than 5, you can let it go. Okay. So mode, as we had explained, okay, we have looked at our frequency. Now let's look at mode. Are you with me? Let's look at mode. We said it's the highest occurring frequency, isn't it? So here we have 2 being the mode, right? And here we have what? 7. And then here we have what? 8 and 6 being the mode. This is for numbers like that. Visible numbers, you see them, that's okay, because 8, 6, they are all occurring 3, 3, and they are the highest occurring. So they are both the modes, and then 7. All right, so that is the mode. When you have, good. A frequency table, right? Someone was asking the modal value in the mode. I would like to, with the frequency table, I'd like to make a certain clarification for you to be clear. When you have the data set as it is, modal value mode, they are all modes. But when you have a frequency table, you realize that sometimes the frequency gives you, it will give you certain values, but it applies to what? It applies to the value that you have, that is the XX that you have. So let's just look at this. You have, we are looking at the number of trainees again. Are you with me? The mode is the value with the largest frequency, isn't it? So when you look at the frequency, the highest occurring is what? Is 6. So here, if you say mode is 6, since the frequency, since it has a frequency of 30, isn't it? You can also say the modal value is 6, isn't it? Yes. The modal value is what? 6. Since it has the frequency of 30, or the mode for the frequency is what? 30. So the modal value is what? 6. It's the same thing. Do you understand? So who can interpret it for me? Anyway, you have interpreted it. So read it. When you read it, you understand, isn't it? 30 students use 6 minutes to find faults in the machine. It means that 6 minutes is the highest occurrence as compared to other minutes, isn't it? So that is clear. Yes, yes, yes. Oh, if you do, it's good. But I put it there for you to understand it better, why it is so. But if you do, it is good for you. Okay? Yes. It depends on the marking scheme. You know, it depends. If you are required to do interpretation, that's fine. I think it's a good thing. We need to add that. No. We need to add that so that at least that should even carry more marks. That will tell us whether you understand it or not. Don't worry. I put it there for you to understand the meaning of what you are doing. Okay? So this is telling us that 30 students use 6 minutes. Student 1, student 2, student over 30, they use 6 minutes. So that means that 6 minutes is the highest occurring. Okay? All right. Median. Yes, please. And your question is, what is your question? Oh, it will be just one. So assuming, okay, from his question, let me explain something further. Let me go back and then give you a scenario. Assuming that 5 is also 30, right? Assuming that the frequency for 5 is also 30, you say that the modes are what? 5 and 6, isn't it? Since they both have a frequency of 30, isn't it? But for now, it's only one. So you just give us one. So median. We said the median of a set of numbers is the middle value or the arithmetic mean of two middle values. When you arrange the data, what? Ascending order. Okay. When we say arithmetic mean of two middle numbers, it means that finding the average of the two numbers. So if you realize that the middle numbers are 5 and 8, so 5 plus 8 over 2, that's it. That's the arithmetic mean. Okay. Okay. So assuming you have a set of numbers 2, 1, 2, 3, 5, then you are asked to find the mean. What do you do first? Yes. And then you find the median position, isn't it? Okay. So if n is odd, then the median is the middle item. For data sets that are not quite a large number, when you do this, you can easily pinpoint it, isn't it? So when you do this, the n means what? Huh? What does the n mean? 1, 2, 3, 4, 5. The number of elements or the number of numbers for this example, okay? So we have what? 1/2, 5 plus 1. So this is 6. So you have the third item, isn't it? So you arrange it in ascending order. Which one is the third item? 1, 2. So this is what? The median. So our median is 2. Even without doing this, assuming you don't have this, you can tell us the median, isn't it? So 4, 2. Okay. So now if you have an even number of elements or an even number of values, they are even. You need to you realize that if they are even, when you arrange them in ascending order, I want you to understand this. Please, can you see? You can see, right? You can't see. Okay, you don't worry. Is that the last question I would like us to solve it? That is why, but let's manage it. Yes. Here, I should cover here. I don't understand you. Okay, you don't worry. Let's just do this because the assignment, I would want us to, so I don't want us to keep going back and forth. I hope, let's manage it, okay, please. So when you rearrange the numbers, you realize that when it is even, you have 2 middle numbers, isn't it?
Yes.
So here,
So the two
have
you
to-
added.
yeah, the 1, 2, 3, 4. 1, 2, 3, 4. So you have 2 middle numbers. That is why when it comes to even numbers, when I say even number, you understand me? I'm talking of the number of elements. When they are even, you need to go a step further and find the arithmetic mean of the 2 middle numbers. And that arithmetic mean of the 2 middle numbers will give you the what? Median. Remember I told you that an average, right, can equally represent the value if you don't have the individual value. So here, if you find the average of these 2, right, even if the average of these 2, assuming you have a data set and you find the average of the 2, and probably the number you get, the number you get after finding the average, you can't see it in the data set. You can still use it as the median. Do you understand? Because it's applicable, it's an average. Do you understand? So that's why you need to understand the concept of average, what it actually means. So here, we know that the number of the data, the number is 10. So you have to find the mean of, yes, you find the position, the median position, that is 1/2/10, that will give you 5, right? And the number after it, that is 6. So you realize that here it is 1/2, 11. It will give you what? 11/2 is what? Good. You realize that it's 5.5, isn't it? But you use 5 because you have 8. Sorry, you use 6 because you have 5 and the number after it is 6. Okay, even though when you calculate, you get 5.5. So you run it to 6, isn't it? Do you understand? Okay, simply put, right? When you find the position, when you find the 1/10, then if it is 5, if this is 5, right? The number after it is what? 6, isn't it? So you find the 5th position and the 6th position. Simple. Okay. 5th position and 6th position, right? Because this is the equation, but when you do it, you get 5.5, isn't it? But you are looking for the number after the 5th position. If you get 5.5, it's still 6th position, because you round it up to 6 to get the 6th position. Because the understanding is that you are looking for the number after 5. The number after this position you have calculated. The number after this position you have calculated, which is 5, the number after it is what? 6. So if you had calculated and you had 9, the number after it is what? 10. So you may even get 9.5 here, but it's 10th position. Okay. Yes, please. You are still not clear. What I'm saying is that when you are finding the median for an even set of numbers, right? The two positions that you are calculating. When you calculate the first one using the formula, right? The next number should be the number immediately after that number. So for here, you have 5th position. You found the position, the 6th position. The next number should be the 6th position. But when I explained to you, I told you that you realize that you have 2 numbers here, isn't it? When you calculate this, the next number is the next number, isn't it? So this is 5th, this is 6th, isn't it? So even if you calculate here, you have here 5th position. You have here 5.5, isn't it? Yes, but it's the 6th position. So if you think that this is going to confuse you, just apply what? 5th position, the number you have, the median position that you have calculated, and the number after it. The number after it. Right? So if here you calculated, assuming you calculated and you had 10th position, the number after it is what? 11th position. Simple. But here when we calculated, we had 5th position. The number after it is what? 6th position. So you count. Where is the 5th position? 1, 2, 3, 4, 5. 5th position. Where is the 6th position? So that is it. We are looking for median. But I said that we need to find arithmetic mean of the 2 middle numbers when it is an odd set of numbers. So is when you find the 2, this one you are calculating the position. You are finding the median of the position. So you realize that this 4 here, you have to find the average of 4 and 4. So the average of 4 and 4 is what? The average of 4 is what? So the median is 4. Please. Confusion. Yes, sir, please.
I think we are looking for median.
Yes.
For the purpose of our exams.
Uh-huh.
I think the median, look for the median. Now we look at that thing that is bad.
Mm-hmm.
The median is the middle.
Yes.
But now that thing that is, but the thing that is, I think the two fours are the middle.
Mm-hmm.
We add it, divide it by two, so it's not going to be
That is it. That is the explanation of all. That is it. Do you know why the formula is important? It's because you may be using a frequency table and you need to apply that. Because for the frequency table, you not have it arranged like this for you to identify the middle numbers and find the average, just like that. Okay.
Why can't we say that adding, when you add the numbers, you do the summation, we have 4 and 4. So we add 4 and 4 to get 8 and divide it by 2. It's still 4. Yes.
That's correct for a data set like this. But you need to understand the formula to be able to do it when you are dealing with your frequency tables. Okay. All right. So, yes, please. The median. Okay. When the number of when it is odd, you don't have a problem. You can easily find the middle number when it is odd because you have the same number on the left, the same number of, on the right. So you easily identify the median. But when it is even, you realize that there will be 2 numbers in the middle. And we are only looking for 1. So you need to find the average of the 2 numbers. In other words, to find 1. That is all that we are saying. So for here, we are saying that when it is odd, you need to find the median position, right, of the 2 middle numbers. And the median position for the 2 middle numbers, right, is the formula that we have there. Half of the base, 10 numbers. So half of 10 is 5, isn't it? And the next number, you know there are 2. So the position of the next one will be what? +1. So that will be half 10 plus 1, isn't it? The next number, right? So if you don't want to use the formula, you can simply get the median position and the number after it. And the number after it, simple. Yes. No, we want to find the position of your next number. I told you that when it's 10, you have 2 numbers in the middle. So when you do the 10, you've been able to find the first middle number. How do you find the second position of the second middle number? It's a number after it. Okay, that is why it's like that. So the number after it is the second middle number. So when you're able to find the positions of these 2 middle numbers, you find the average of those numbers. Then you get 1 number, which will be your median. It's just a coincidence that we have 4, 4 here. We could have had what? Assuming it's 4, 5, 2, right? So the median will be what? 5 plus 4 is what? 9. 9 over 2 is what? So our median is 4.5. Even though it's not here, it's an average and it still applies, as I've explained to you what an average is.
Thank you, Madam. So, Madam, let's say, for instance, you've been giving a data set like this, not in a frequency table, and the number of n is odd. instead of just going through the formula and just writing half 10 plus 1 position, if you stated from observation, the median is, let's say, 7, is that acceptable?
You know, when it comes to mathematics, how did you arrive by it? Observation. When I'm marking, I didn't see observation. Oh. I wasn't there when you were observing. Yes, I wasn't there when you were observing. So you have to show me how you arrived about how you arrived your median. Okay. You may do your observation, but I wasn't there. Okay, that is why when you are doing the mode, if you tell me that the mode is there, you tell me why it is like that. Okay, so that okay, and so okay, this is how you arrive by it. So that one too, you have to do it. Okay, so we have explained this. Right? So if you have a frequency table like this, are you going to list all 120? I don't know, is this 120? If you have 120 observations, are you going to list 120 observations and then start counting and be looking at where is the middle number? No, that is why the formula is important. Okay. All right. Why is our still like this? Why didn't it come down? But you can see. Okay. The table gives the number of accidents had by 60 drivers last year. What is the median of these data? So 60 is what? Good. So you need to find the median position using your 60 and the number after it. So when you do 1/2 by 60, you get 30th position, isn't it? And the number after it is what? 31st position. So you look at your data. Then you add your frequency to get the age corresponding to 30th and 31st position. So when we start adding 15 plus 9, 24, 24 plus 6, but 30. So at 30, we have 2. So you write it, you have 2 here. Then you continue. What do you get here? 49. So within from 30 to 49, your 31st position is found in here, isn't it? So you have 3. Okay. So you find what? The average. Then that will be your median. So you see our median. Our median is what? It's 2.5. Do you see 2.5 on the table? Do you see 2.5 on our table? But it's an average, so it applies. Okay, that's why you should understand what an average is. It's an average. So it applies, right? So the median is 2.5. Yes, please. No. No, you can't do that. Because remember, you have 3 and you have 2, isn't it? And you want to find the middle ground for 2 and 3. So if you approximate it, then what you have done is cos 90. You know what cos 90 is? Okay, so let's move on. Okay. So this, we are going to do it as a class. This one and the assignment, we are going to do it together. Where is that? Can someone clean this thing for us? Okay, let's do this. So calculating the mean. We say, how do we get the mean? How do we get the mean when you have a frequency table? How do you get the mean? Okay, so what do? We add fx. Okay, so that's what we'll be doing here, isn't it? So you can create another column here, then you add up, then you get your fx. Okay, you sum it up, isn't it? Then get your sigma fx. Then you sum your frequency, get your sigma f. Okay. So the mean mark will be what? 4.62. Agree. The assignment, you do it too, so follow. After that, I'll sit here and then you people will do the assignment for me. Okay, so the mean mark is 4.6, right? Median is even, right? It's even. So that means that when you find the first middle number, which is the middle position, which is 1/2/20, because we have total of 20, isn't it? So you have the 10th position, and the number after it is what? 11th position. So you go back to your frequency table, then you add up to get the values for your 10 and values for your 10 and 11th position. And 10th position, we have 4. 11th position, we have 5. So your median is what? 5, right? And the modal mark is the observation with highest frequency. Hence, our modal is 5 because it has the highest frequency of what? 4. Okay, so this is for you. We are going to do it. Oh. Okay, who is coming? Oh, definitely, I'm not doing this. You do it. You do it. The last time you were on the board. Let me get someone else. Go and do the first part. Okay, you know what? Do the fx for us. You'll find the sigma fx for us. Just draw the table for fx, okay? So that You draw it, you can draw it so that we have everything there. Okay, makes it small.
You can't see. All right, today, you. All right. So x and f. So fx is multiplication. So 2, 1 times 2 is 2. 2, 4, 3, 5, 4, 6.
Come for the mic.
Thank you very much. 4, 6, 24, good. 5, 10, correct. 6, 1, thank you. 7, 2, hello. 8, 3, 24. 9, and then excellent. So we have our F. And please, I'll answer you after we are done. Thank you very much. Yes. Okay, don't worry. So we know that the formula for our mean, which represents like this, is not pi. So when you are writing, please remember that the mean is not pi, it's x with a dash on top. It is sigma or summation. You can see. Please come and sit in front. Summation fx or sigma fx over sigma f. So because I explained that sigma stands for summation, so it means that the summation of all of this is sigma f, and the summation of all of this is sigma fx. So summation f, those that have calculators. Let's go. Wonderful. 35. Beautiful. So our sigma f is 35, which, if you observe, is even in the question for you. And then our fx, calculator, 162. Excellent. So we have our figure for this and our figure for that. And then it's just simple substitution. So we input the data. Fx is 162, and then f is 35. Okay. Then we use our calculators. We get what? 4 point what? 4 point. All right. So we are using 1 decimal point for this. So we have 4.6. All right. So our mean, the mean mark. So you have to write it in the exam, right? Hence, the mean mark is 4.6. When you leave it like this, it's -1. All right, thank you very much.
Thank you. Yes, he deserves an applause. Thank you very much. Modal. Oh, look, our M didn't come. Anyway, modal mark. And sorry. The median mark. He's done most of the work. So the median, who is coming? Median. I should choose at random. No one is volunteer. Okay, I'm going to choose. Those have passed by. Don't think you are free. I may come back. And median. Who is coming? Thank you. So our median mark. The formula for the median is half of the sigma f is an odd number. Sigma f is the odd number. So since it's an odd number, the formula is half of sigma f plus 1. So plus n. Oh, 1. So how sigma f is 35 plus 1. And half of sigma f plus 1 is 36. Half of 36 is what? 18. So to be the 18th observation. So we'll now add the frequency. That will give us the 18th observation. So 2 plus 4, 6 plus 5 plus 6. So plus 10. So our 18th observation is around the 5 level. So our median mark is 5. The 18th observation for the median mark is 5. Thank you. You all agree? No.
Madam, okay, per the formula, as a median, the half of let's say the sigma f, which is already an odd number, 35. To me, what I did was I divided the 35 by 2. That's the half of the 35, which is the 17.5. So the 17.5, meaning the 17th and the 18th observation will be the middle, it will be the middle number. So the middle numbers that we had have to be, it ranges between 4 and 5. Like the mark, it's within 4 and 5 when you are counting the top. So I had 4.5 instead of 5. If n is odd, then the median is a middle item, i.e., the 1/2 in bracket n plus 1, and then raised to the power th. Item or observation. And then since n is 5, median position, half of 5 plus 1, which is also equals to 1/2 into bracket 6, equal third item. Hence, the median is 2. So mine, I didn't add the 1. From the evidence on the blue sheet, it means that I was close.
Madam,
half of 36 is 18. How come it got a 5? That's where baffles.
That's the 18 you get here. It's the 18th. That's why we have THF. It's the position. So you add up your frequency, so you get to 18th position. The value at the 18th position is your median. Are you okay?
So the simple explanation is that you sum up your frequency, which is the 2, 4, 5, 6, 10, 1, 2, 3, 1, 1. You rearrange them. So you get 1, 1, 1, 2, 2, 2, 2, the frequency. So that you get the median one, which is the 2, 3.
When you are dealing with large data, you don't have the liberty of time to be doing that. I wouldn't encourage that. There's 35, so that means that you would have to write this 2 times, 8 4 times, this 5 times, 6 times. That's the meaning. Sorry. Yeah. You have to write this 2, this 4 times, this 3 times. You have the liberty of time to do that. Okay. By the time you finish writing, you can even have an object like this. By the time you finish doing this, someone has even answered 10 questions already. Rearrange what? No, you can't rearrange them. That one you are seeing here is telling you that 2 is occurring, 1 is occurring twice. 2 is occurring 4 times. 3 is occurring 5 times. So you are going to write 1 1 1 1 2 2 2 2. Honestly, I wouldn't encourage that. But if you think you can do it like that for the median, but you don't do that for the mean, because for the mean, I'll come to you. For the mean, when you have large data, as I said, the relative frequency gives you a better estimate. Okay. Yes.
Yeah, marking 5, and it's at the 18th position, and you are marking my script. How would you score?
You lose a mark because you haven't answered my question. I'm looking for the median, and you're giving me, I should do the calculation. You get some marks, but you lose some marks too. Okay. There was a hand raised, yes. When you are looking for the median, the value for the median is not the frequency value. The value for the median is the values you have there. Is the frequency is just giving you the position. You'll be adding the frequency to get the position where you find your value. That is the X. So the 18th, you are adding your frequencies, right? And you realize that when you get to frequency 10, your 18th position is in there. And your median value is 5. Okay. Just understand that. You would want to answer that.
Madam, please put our formula on the board. Yeah. If for now, let's say for the X, we are finding the mean, the median, and the number is not, let's say, odd or even number. For now, I have 1 to 10 here, and I'm supposed to find the median. I will go in for 5 and 6. And please, I get what I'm saying. No, you have to listen to me what I'm saying. Yeah, you see, you have to, because for the formula that you taught us here, is that if you are given from 1 to 10 here, and you are supposed to find the median, you can't go in to find the 5 because the 5 is not the median, but the median here is 5 and 6. Please, are you getting me? So for the 5 and 6 here, that means you have to use the formula 1/2. Then we find the formula, the 5 number here for the student 5, then plus 1.
Is 35 an odd or even number? What is the rule for odd when you are looking at odd numbers? I'm not saying odd numbers, I'm meaning the frequency, the total frequency is odd. What is the rule for that when you are finding the median? And which formula applies to the odd? Because if you use what you are saying, you will get it wrong because you are looking at the values. And then because you have 1 to 10, you think that the middle number is 5 and 6. No. That 5 and 6 you are seeing there, 5 is occurring 10 times. So when you do your data, raw data, if you have your raw data, you have 1, 1, 2 occurring twice, 2 occurring 4 times, 3 occurring 5 times, 4 occurring 6 times, like that, up to 35. So that your 5 and 6 may not necessarily be in the middle. Do you understand? If you are not getting it, simply apply the rule. When the total frequency is odd, you use this half n plus 1. You get the position, add your frequency to the position, and add your frequency to get the position. Then you find where the value is within that position. Okay? But if it's even, that is when you use the number after the median you've calculated. Yeah. Okay. Don't confuse, don't think too hard. Okay.
Madam, if I'm understanding clearly, if your answer happens to be in an odd number, as we have the 5 there, we are only looking for just a single position. But if the answer happens to be in an even number, we are looking for 2 separate positions.
The odd and even is in relation to what? When I say odd and even, I explained that when it comes to your distribution table, we are looking at total frequency, whether it's odd or even. And when we say frequency, we mean what? The number of occurrence. So here, the frequency is what? 1, 2, 3, 4, 5. There are 5. That is n. The number of occurrences. Okay. Okay. Yes. And that's because it's even. Yes, if it's an odd, you are looking for 1 position. But if it's even, you are looking for 2 positions, right? You look for the first, because if it's even, you have 2 numbers in the middle. So you have to identify those 2 numbers and find the average of those 2 numbers. That is it. Okay, so you realize that here is 35. So we'll look for just one position. Then use that position to find the value. Okay. So our time is up, but let's just. So that is it. Yes, I wish you all the best. And I made an announcement that I would give out an assignment. Please, you should all endeavor to do that assignment. I will not mark any assignment after that deadline. I'll repeat it. After the deadline given, I won't mark any assignment after that deadline. I'm going to give you 1 week because some of you don't have any marks at all for whatever reason. Some came late, so they couldn't have access to to the assignment. So please, and this assignment will be over 40. No. The more you have assignments, the better positioned you are. So nothing is gone, but I'm just imploring you, do the assignments, okay? And the exam too, it's so the exam, you have 30 objectives and you have a written part 2, section B, where you have 5 questions, you choose 2. Okay, and it will cover all that we have learned. Okay, it will cover all that we have learned. Come with your calculators, no phones, please. Come with your calculators, no phones. You have a question? Yeah, I think section B, the written part will be 5 questions. Then you choose 2. Then you have 30 objectives. It will cover all the topics that we have learned. That is for the exam. Okay. Yes.
The way you said the steps we are not right now, already you are aware that 40% of the result
Oh, please keep quiet, please. Not necessarily. It depends because in all respects, we don't want anyone to fail. We want you to do your best and get it. That is why you are giving more assignment. Do you understand? Yes, to cover wherever is lacking. So please do well and do it. Okay. If you've done all the assignment, that is good, but do this one. That is all that I'm telling you. Okay. All right. So I wish you all the best.